Welcome to physics class. Today we are going to learn how to plot a graph. As you can see, a graph of force F against distance D in centimeters. So the first thing you have to do is to write the heading of the graph. That is a graph of force F against distance D in centimeters. So after that, the next thing to do is to choose appropriate scale, vertical scale as well as horizontal scale. So in a vertical scale, what is going to be plotted on the y-axis is force. So considering the units, the largest unit is 2.4. So after analysis, we get one unit is going to represent 0.2 Newton. In horizontal scale, the highest point is 70 centimeters. So one unit will represent 10 centimeters, so that we can cover 3/4 of the page provided. So every graph you are going to draw, it should cover 3/4 of the space provided, both on y-axis and x-axis. So the next thing is you get a ruler, then you draw the axis. You start with the y-axis. In my case, I start with y-axis, then the x-axis. So you put the arrows to show continuity of the variables on both y-axis and x-axis. You also label 0 mark at the origin to indicate the starting point of each axis. And the next thing, you label the independent and independent variables. In our case, distance is on x-axis, then force F in Newton on the y-axis. So that at a glance we are able to know this is a graph of what against what. From there, according to our scale, y-axis, one unit is representing 0.2 Newton. So you make sure that you go as per that interval until you surpass the last point, which is 2.4 Newton, so that every point is covered within your graph, within the range of your drawing. So in my case, I go up to 3.0 Newton. You do the same on the x-axis, depending on the scale provided. One unit is representing 10 centimeters. So you make sure that you also surpass 70 mark, so that every point is covered within the range. From there, the next thing is plotting. So you start plotting on distance 10 centimeter against 0.8. So you identify where the 0.8 is, Newton, and the 10, where they are going to coincide. In my case, it is there. So you have a cross there. I prefer cross to a point or a dot because the cross is easily visible. Then the second point, 21.0. Third point, 30 at 1.2. Fourth point, 40 at 1.2. Go to the 50 point, 50 at 1.8. Our sixth point is 60 at 2.0. Even without drawing the line, you can see the points how they are varying to give you either a line or a curve. So that is our last point. So the next thing is to identify the line of the best fit, and you do so by considering different points. So in my case, if I have those 2 points in line, we are going to have most of the point even below the line. If I consider the 3 points in between, we are going to have the line of best fit, some lines below and others above the line. So in my first case, if I consider the 2 points, most of the other points left are below the line. So that one will not be the line of the best fit because the error is not evenly distributed. Remember, if the error is not evenly distributed, then our conclusion and our final slope and the gradient will be too far away from the accurate value. If I consider the second 3 points, I can see 2 points are above the line and the 2 points below the line. So that one can give us the line of best fit. I also consider the last 2 points there. You find that the 2 points are going to be in line. 3 points, of course, but no points below the line. All the points are above the line, the others which are not fitting in the line. So I don't consider that one as the line of best fit. So I have that one as line 1. The 3 points in between, I have them as line L2. Then the last 2 points, I have them as line L3. That is the reason I'm using the dotted lines, because I have not drawn the final line. I'm cross-checking. So that is my line L3. So if you consider the 3 lines, you choose the line in which the error is evenly distributed. We might have some points above the line and others below the line. That is to mean if the line is passing in between the points, the error is evenly distributed. Everything is catered for. So that is my line. So my line L2 becomes the line of best fit. So that one is the line of best fit, because you can see, as you can see, we have these 2 points above the line and the last 2 points below the line. So in other words, L2 is passing in between the points within at least 3 points within the line. So 2 points above the line and 2 points below the line. So that is how you plot a graph. You make sure that you plot all the points. The scale is there, the heading. Then we have the marking. So next time I will be talking about the marking of the graph, how it is done. But meanwhile, let's give ourselves some points. You can see plotting is given 2 marks there. That is because you have plotted more than 3 points. Our total points is 7 points. So if you plot more than 4 points, you get the total 2 marks. If you plot below 3 points, you get 1 mark for plotting. So our graph has a total of 5 marks. So when you do everything perfect and correctly, you get all the marks. So you confirm whether the variables are there. You confirm whether all the variables are there. You can see the distance on the right side, also on the right side of the axis, also the heading. The graph has a name. The graph has a scale. As you can see, the scale is evenly distributed and well placed. Then the line of the best fit considered. So that was a graph of force F against distance D in centimeters. So next time we will be finding the slope